There's a drill bit on the end of some 4.5-inch drill pipe. In order to hold the hole open, we have to run steel casing down through it. Just start on the top of the ground with a 20-foot section, run that in, undo the tool joint from that first drill rod, and add another section of steel casing with a drill rod inside it. It's just a continuous process. The air compressor blows air down through the drill bit. The drill bit's grinding the material up at the bottom of the hole. There's a drive shoe on the end of the casing. If we hit some hard rocks or something with the end of the casing, it just keeps the casing from bending. That drive shoe is a little bit bigger than the outside of the casings, and we follow that down with a bentonite grout on the outside of the casing. Make sure it's not a conduit for pollution, if you had a spill of some sort, that it wouldn't follow the edge of the casing down into the aquifer and pollute the aquifer and your well. We'll cap the well when we leave here. We'll weld a steel cap on it, and then they dig a trench deep enough to the house that the water line won't freeze. A fitting called a pitless adapter that lets the water make a 90 out through the casing at ditch level, so your water doesn't freeze in the wintertime. Probably a submersible pump inside the well, which will hang on what we call drop pipe. Electrical wire runs down there to power that pump. Usually put the pump about 10 feet off the bottom of the hole. It pumps the water up to the pitless adapter, underneath the ground, into the house, and into a pressure tank.
So I know with wells, one important consideration is the depth to groundwater. Can you talk a little bit about how you want to consider the depth of your well and water table?
Well, when we're thinking about water quality and water quality protection, the thickness of what we call the unsaturated zone, or the depth of the water table, is critical. The deeper it is to the water table, the more protection there is. And of course, the type of material involved comes into play as well. If you've got thick silts and clays, it's probably a pretty darn good filter. If you've got thin gravels and sands, it's probably less effective as a filter. Typically, when the well is constructed, the well driller has created this path of least resistance through those soils. And when they construct the well, usually they'll place a cement grout or a clay grout around the casing, which seals off that path of least resistance.
When a well is drilled, is there a record kept of the information about depth to groundwater and the material used?
You know, absolutely. When a driller completes a well, he will record on paper what exactly he encountered as he went through the subsurface. The record that we call a well log is something that records conditions at the time the well was drilled. So it will have a depth to the water table that was effective or accurate at the time the well was drilled. That can change over time.
So what are some of the things that a well owner needs to consider for protecting their groundwater resource?
A person should inspect where the conduit for the electrical wire goes into the well cap itself. Oftentimes, over time, that conduit will pull down, it'll settle a little bit, and presents an opening into the well cap and into the casing. Sometimes that can be large enough for a rodent to get into it, and you do want to keep mice out of your well. Look at drainage around the wellhead itself as it sticks up out of the ground. This well in particular is on a relatively high spot on the parcel, which is good. Drainage is positive away from it. Then as you get to the wellhead itself, the type of cap that's on top of the casing, whether it's what we call a sanitary seal versus a cap, we're typically talking 220, sometimes as high as 440 volts going down to the pump, and you really don't want to be messing with the cap unless there's some reason to be in there.
We've been looking at new style construction, where the water flows through a pitless adapter below the surface into the house. An alternative configuration is common in older construction, where the wellhead and equipment is contained in a pit, or possibly in the basement of the house. What are some configurations for a pit-type well?
They could be square like this one, which is concrete. They could be round, or they could be like a metal-type culvert. Often on older ones, they'll be like a square concrete pit, and it'll have a roof structure over it, perhaps triangular little house. Looks like a small dog house.
So what is the purpose of the pit in this wellhead situation?
The purpose of it is to protect the pressure tank, plumbing, other components, electrical components, again, from exposure to the elements, from freezing.
What are some considerations for safety around a pit wellhead like this?
Right. The first thing is just to examine the structure of the pit itself and the covering over it. Look down the hole, make sure there's a good sound ladder. Is there any exposed wiring?
Do you want to show us what's going on inside the pit itself?
Sure. Let's climb down in and take a look. So the components we're looking at here are a pressure tank. This is an older pressure tank, but still functional. As the individual starts using water in the home, the pressure will go down, and a component called a pressure switch down here causes the pump to kick on. From the pressure switch, there's wiring going to the well itself. There's also wiring running up here to the control box, and in this situation we also have a fuse box. Typically you'll see a handle type shutoff. So as the pump turns on, the water will come up through the pipe in the well into the pitless adapter, where it changes its motion from up to horizontal into the plumbing, and of course directly into the pressure tank. From the pressure tank, the pipe will go below the frost line and into the house. Usually if you have your actual well in the well pit, it's usually closer to ground surface. In the pit that we're looking at today, it's very well insulated, so the threat of freezing is fairly low. But in the situation where the pit wasn't well designed or well insulated, wasn't a heat source, and you have a freeze up, in most situations you're going to flood your pit. If you have a situation where the well was at the ground level, of course the easiest pathway for that water is down the well itself. And in some situations we have seen where people stored things that they shouldn't have next to their well or in their pit, such as pesticides or oil and grease, household chemicals, and have contaminated their own well by storing those in their well pit.
So another thing that I look at when I look at a wellhead and consider, potential impacts from activities on the surface, I look at the landscape, the vegetation that's here. This is kind of not a mowed area, not a manicured area. It doesn't look like it's heavily fertilized, if it's fertilized at all, which is good. Minimize the potential for nitrate impacts to the groundwater here. I also notice there's broadleaf weeds or plants around us. It means that he's not doing a broadcast herbicide application, which is good. If you can stay away from your wellhead with herbicide applications, that's just being protective of both the water in this well and the groundwater resource in general.
So as far as keeping track of what's going on with your well maintenance or with water quality testing or with septic maintenance, do you have recommendations for people to keep those records?
We do. We think it's important to keep records both for yourself and perhaps any future homeowners. We recommend something like we see here on the table, the use of special folders that are one for water and one for the wastewater at your house. It allows you a place to put down some record of what the maintenance has been.
You can inquire with your local extension agent about folders for your well and septic system. There are a lot of responsibilities that come with owning a private well. Protecting the wellhead, being conscious of land use practices around the well, regularly testing the water quality, and keeping good records of those water quality results and any maintenance that is done on the well are critical components of helping you to protect groundwater resources.